bundles and we'll show. Whichever.
Thank you. So, hello everybody. I try to speak fast so we can try to not too late anymore. Pocket duplex light rules, the cursor, how they evolve. We have this is the two main families, 82 and 83. There's another one, I think it's 163, that's H3, that is for school, and I've seen pictures of their black Xiaomi, that's also a duplex of light rule. But these were the most common, and you see there's changes in shape, there's changes in the scales of course, but well, I concentrated in the cursor. In the cursor there were nice changes, and we can see in this family I found 4 main types of cursors. So the question is why? Okay, so we can think of technological reasons, technology improvements. We can see, or we can think about market, needs to sell, needs to be better in the market, and also maybe some topological changes. The first thing to see is the dating of the changes. Okay. For this, what I have used is the book from Peter Holland. Because it was difficult for me to see exactly when these changes were being used. I will explain mainly about type 2, okay? But I used the timetables of sailings for these slides for you, so you can take the idea. Okay, so main issue is, well, I have not found any literature for the names of the different parts of the cursor. So, excuse me, I have taken names by my own, and maybe we could discuss about why use this name for this, why runner for what is in the bottom and the top of the cursor. Well, use this, try to think about this only for this presentation. It's in the book, I think it's page 37, if somebody wants to remember what I'm speaking about. The idea is that cursor is the big thing, window is what you use to read things. We have the top and the bottom runners. We have the hairlines, the central one and the peripherals. We have text, and then we have marks. Okay? The spring strap and the closing screw and nut. Oh, sorry. Also the sliding rods, these metal elements here, I will explain later. First type, 1956. The picture is only from one of the families, but you can see equivalent for the, this is 6282, 6283 is pretty the same. Okay, white runners and of course transparent plastic for the window. Green text from the names, and the first thing is why this shape. Okay, so you have why this width, why this height, and why this protruding of the runners. Okay. Well, I have taken this picture to say, well, was not possible to make the window bigger if you want to have the window when you're having the window at the end of the right rule, maybe the hairline to reach the 1. So this can provide one of the dimensions, but of course the length, of course, of the runner. The thing is, well, not to come out from the rule, but you have a wide range, maybe some aesthetic. Also, one comment about aesthetics is there are some of these cursors with this shape square, not rounded corners. Okay. This is also evolving in the next types, so I understand that there were some aesthetics here that showed that it was better to use rounded corners. So, what about the details to manufacture this? Sorry. The plastic window, okay? Planar plastic in that time was acrylic resin called Lexicon. There's holes at this side and at this side of the plastic. You can see here at a side view, and the white runner also is inside of the window. So the idea of how this was manufactured, so you should have some kind of liquid resin, so you have some kind of mold or hole where you have the shape of the runner, and then you pour the white liquid component to get the shape. By doing this, then you fill in all the holes on the plastic and you ensure the perfect fixation of the runner to the window. Okay? And of course, from the shapes of the mold, you get the shape of the runner. Okay, so let's go for more details. Well, sorry for the pictures. I'm not an expert in photography, but maybe you can see. This is one of the halves of the cursor. You see the spring strap that has been riveted, okay, with a nail. In the bottom is the nut for the closing. Well, the idea is that this nut was pressed after the piece was manufactured, and this is the element to ensure the closure of the two halves of the cursor. You see this is quite big. I guess this is because of the plastic was soft, so they need some big element to ensure robustness, and maybe because also the tolerances of the project, the process might not be so nice like we are used now, so they need to go big. There are some metal rods, okay, that were used also to close this assembly, and the purpose of this was to ensure the centering from one side to the other. So I guess that they closed the cursor, they made the holes, and then they put the rods so they don't move laterally. Okay. So well, there's a piece of technology here that we can see, and let's think about the lines and text. Okay, the picture not very clear. We have a red mark for the peripheral lines and black for the yeah. There's one thing I have missed to explain. Here, aesthetically, there's some decisions also about the markings. You see that the red lines, more or less, the distance towards the edge of the window is equivalent from the left to the right. And this meant that the central line is not central, is somehow shifted. You see here to the right and here to the left because of the symmetry. Okay, so this is something also we will see in the next types. Okay, so we were looking about the lines. They are very clear lines, and the process is cutting this line from top to bottom, bottom to top, and we will discuss a little bit about how to get this very fine line. The key is in this one dividing tool. I'll explain later. Once you get the marks in the plastic, you print with red color or black color by rubbing, like kind of a stamping, and then with a wet polishing to clean everything to get the lines as they are. For the text in the external side of the runner, you have something different. Okay, you can see here very clearly some increase on the plastic. Okay? This is the signals of thermal printing. I will explain the next slide about this so you understand. Okay? And of course, when you get the text, then color rubbing on it and wet polishing for getting everything clean and clear. Engraving or marking the lines. Okay, so when you have a plastic surface and you try to use a cutting element to make line, the normal thing in the plastic is while you are cutting, you can get bits of the plastic broken. Okay, and these bits of the plastic broken when you are cutting makes that this line is not clean. Is in the end you get a bigger line. Okay, when you paint. So the trick here was to heat the tool. Okay, when you heat the tool, the thing is that the point is not melting, of course, but is making the plastic smooth. Okay, like say butter. So when you're cutting butter, you're not getting bits because the butter is kind of soft, and so you could clean and you get a very narrow line. Okay. Regarding the text, the thermal printing is you have a metal head with the text protruding, okay, from it, and this is hot all the time. So when you got the plastic and the head touches the plastic, these points melt the plastic and press in the plastic. So this has to be the plastic that was here needs to go out, and this is what you see. Okay, this increase in the plastic surface means that the plastic has to leave where it was before. So this is the typical shapes in the thermal printing. Okay. So let's think about second type. Second type is in the same slide rules. There was nearly 11 years, so it proved that the previous type was very good. Okay, so nothing to say. I have put a question mark because it's not a clear date. And why 1967? Because I have found rules with a white cursor in 1967 early, and by the end of 1967 I have also found rules with already this one. So I guess should be the time maybe by the end of 67, 66, this could have started and maybe some overlapping, but let's consider this. The first thing we can see is a total plastic injection piece. Technology has improved. If I have to provide a definition, I would say perfect technology. Okay, I will show afterwards. So they went to the top level of the technology capabilities. Okay, again, 2 halves of the runner at each window. Now we have black, we have forgotten about the red. Again, there's the same distance of the peripheral lines, so the center line, you can see compared with the screw nut, is not in the center. Okay? We have now text, letters, and the marks, also some changes in the stuff that we will see afterwards. Okay? So the details. Okay? This comes from an injection mold. Okay? I don't know if you have all know about this, but this is something that you have 2 cavities and you press inside hot plastic, so the plastic fills everything inside, and then you get the shape that you have generated in each side of the mold. So what we see here first, the holes for the spring strap that now is placed by hand, no riveting, so simple process, high technology. Okay, and of course it remains in place, no problem. Okay, see this narrow, we will talk afterwards as a comparison. Second point, the fixation elements for the closure. Now we see this is very, very small. First, the plastic may be more robust, but also the technology enables a very good degree of tolerance. Okay, so there's a very a small element, and it's enough to ensure the closure of these two parts. The counterpart, so this will be the holes. Okay, this is one part, and this is the other. Okay, so these holes are wider. So this is the dimension of this is smaller than this one. Why is this? This is to help movement when you have the device closed. So this is shown that in the assembly line it was easy to ensure the centering of the lines. Again, a technological advance was simplifying enormously the productivity of this element. Okay. Number 4, well, this is some ergonomics, aesthetics, or whatever. There's some grooving in the external top and bottom of the cursor, so it's easier to handle. Okay. Here we have, I guess you see, there's some cut, or there's some, the plastic is going lower, so we have a kind of a square, okay, hole here. That you can see here in the lateral view, this small dent here, okay, it's the same as this. This is to prevent top and bottom positioning, okay. So the idea is that this hole is only in the top side and it's not in the bottom side. It's not seen here clearly, but the idea is that with this you prevent wrong assembly from on top and bottom, okay. Again, simple process. Afterwards. This, as you see, there's an increased thickness of the surface in the internal side of the cursor. This is to provide a gap, small gap between the lines and the scales in the body. You can imagine this is to prevent the friction, to make the scales clear, and to avoid any marks in the cursor while moving by this small increase in the plastics in the top, and also it is also in the bottom. Okay. And finally, you have metal rods. These two metal elements that are on the bottom side of the cursor. So you are with this you are having a kind of 3 points of fixing of the cursor. You have in the top side, you have a spring strap in this position, and then you have the bottom two other elements. You ensure perfect perpendicularity of the cursor in front of the scales. Well, at the end there's a hole for the hand disassembly that is kept like in the type 1. Okay. Something about the question now, you have seen the metal elements, is how these metal elements were placed there. So some adhesive, or what, there's also a possibility to have them while you are injecting the plastic. Okay, so I have explained a little bit about the injection of the plastic. You melt hot plastic is put inside of the mold to get the shape, so it fills everything inside of the mold. Okay, small. And then you get the piece out. If the metal elements, okay, were to be put, this is a possibility, it's what they are called inserts, that you put the metal elements before you're injecting the part. The result for this, once you get the piece, is that the part of the metal element that is touching the plastic is absolutely surrounded by the plastic. There is no gaps, no air. So this is the way you ensure the component in place directly from the mold. But this, it's not an easy thing, and it's quite tricky. So let's see what they did by that time. This is a big pictures, okay? This is the nut for the fixing the screw. And I don't know if you see, but these are the star shape of this nut, and you see here there's a hole. Okay, so you can see clearly the cylindrical hole that was made before this part was inserted. Okay, so it clearly shows that this element was placed after the plastic was injected. No problem. Okay, it's a good shape to ensure that there was no rotating of the nut, and it was, everybody knows that this is working perfectly. So there's no thing about this. And then the rod, the sliding rod, you see this surface is flush with this surface. So this part, if it was from the mold, had to be filled with plastic. There cannot be air gaps. And also, this is a complicated picture because I was taking the advantage of the transparency of the cursor. It's not cut. Okay. So you can see here, this is the internal part of this rod, and then you have here the hole in the plastic. So there's a cylindrical hole again, and then the rod is entered, so you can have some gap here. So it's done after the plastic is injected. Okay. I will talk a little bit afterwards with the other types. See here some melting on the plastic. I will discuss afterwards. Okay. So text. The text in the face is very clean. Okay. So you can see also this one that is thermal printed like in the other case, and you see here like I mentioned before, this plastic increase. This shiny area here shows a plastic increase for the thermal printing, but you cannot see that here. You see here the clean surface and no distortion of the surface. So the conclusion is these letters come from the mold. So the mold was had the text, had the lines. So when you printed the plastic, you already got the markings and the text. Of course, this is the best thing to get the text in place, provided that you have the technology to make this. But the contra was that you need one mold for each of the two models, because the lines are different and the text is different. Okay, so you have very good marking, but the contrary is that you need two molds. Then the other question is, if I have used the mold to make this text, why don't use this mold? The mold also can make this text. Well, I don't have information. I can make a guess. First would be the complexity of the text. So there's round shapes. There's a special type of these letters. Okay. While the letters in the face are simple. So maybe there's some technology difficulty on making this type of text nice, because it's for the looking in the mold. And the other thing would be that this text is done in all the rules in the Faber Castell factory. So they will have a specific process step for this marking, and this will be used for all the rules, all the slide rules in that factory. So it was a very cheap process step, but because it was very used for a lot of models. Let's go to the next cursor. So if the second type was, I would say, with a level of perfection, this is optimization. This is cost, goal. This is market focus. So the first thing, you see the second type was white in the window. This is again having a narrow window. Shows that the slide rule is smaller, so I am saving plastic. Shows that also I am saving the plastic in the cursor itself. We can see we can see a different thing here. The peripheral lines are not symmetric, so we have lost the symmetry. Why? Because now the central line is central with the face. So there should be some aesthetic decision in the meantime, because this central line should be in the center of the window. Okay. The shapes, as I told, of the runners are round. Okay. So let's see what we have in the details. the holes for the spring strap. I mentioned in the previous case that were narrow. Here you have them wider. There are two reasons for that. First is more robust. The metal element, that is a very small metal element here, is bigger, is stronger. Because the plastic, when you inject the plastic, you make it at high pressure because you want to fill everything. So there's high pressure, and then, believe or not, the melted plastic somehow ages the metals, can break the metal in hundreds or thousands of manufacturers. So having a bigger hole means a bigger metal element and then more robustness. Also indicates a different or more complex mold, because the previous mold was a 2 halves mold. I guess this one had at least 3 or 4 halves to get this. Well, it was of 1970, so it's 3 years, not much time difference, but of course the technology. The only metal element here is the nut, and I can show you directly that is again inserted after the plastic was injected. We have again the same elements for fixation. We have still this hole. Well, not seen here is the counterpart, the square element that is entering this hole, so you can again prevent putting top and bottom wrongly. The sliding rods now are made from plastic, so there's a clear saving in money. You don't have another component, another metal element, and you don't have to insert this. You're getting this directly from the mold. Okay? Robustness, of course, there's a loss in the robustness, but of course the study for sure was that it was good enough for the life of the slide rule. Okay? We have here, I don't know if you will see also, in the previous types, I was mentioning about a plastic surface that was preventing from the central area of the window to touch the surface of the body. Here, we only have this small, here you have these small elements that are making the same. But why? Because here, if you see the slide rule, here you have numbers. The slide rule is optimized in the height, so the scales reach nearly to the edge of the slide rule. So the cursor could not have this extra line here that would complicate the reading. So they had to limit this phase only to the small elements. Okay, that's another indication of reducing the cost of the slide rule. Okay. Finally, the hand opening is also shaped directly from the mold with this square opening. This is another indication of this I mentioned of 4 parts in the mold. Text. Here we see again this shiny area indicating thermal printing. Okay. The text in this window is thermally printed. Okay, I understand that the printing process in this time with thermal was good enough to go into the window, but not so good like in the previous one. You can see the text is not so nice, but good enough. And what is the advantage of that? That you can get a single mode for both models. So let's see more or less the process would be, I injected the 2 halves of the cursor, I place the nut of course, then I engrave the common markings, maybe the central cursor, and maybe some, the lateral of course lines, and then with thermal, everything, this and this is thermal printing, I make specific markings, and then the black color being wrapped in the text, and of course the wet polishing. So I have a common process for the 2 components. I have simplified all the assembly costs. So this is a say lower cost element or slide rule for a higher market and a high competition. So the idea is that here I have strong competitors, I have to fight against them, so I need to have something, let's say, more affordable for the market. Okay? And then let's go to the fourth type, 1972. This is the big one, the N family. And what we can see a strong similarity with type 2. Okay, so we have big window and we have all the plastic for all the shapes. So the idea that, well, let's see, this will be also top quality design. Let's see what happens, but I would say this is an intermediate. So this is top quality, but taking the advantages found from this type 3. Okay? Again, the center line is central. Okay? It's not so clear, but this distance is not the same, and then this distance is not the same as this one. Okay? So let's go to the details. We have the same elements. I have one picture here showing that the elements in the top and the elements in the bottom are slightly moved from one to from the other. So in fact, only with the assembly elements you cannot put top and bottom. So you are preventing the wrong placing of the cursor already from the assembly elements. Okay, this made that small cut that was here in the plastic has been taken out. Maybe also they consider that the engineer that is assembling this will take enough care to do the things right, so it's not so needed in the end. But you know. Okay, so we have this, the nut, again, same like in the other case. The metal rods appear again in this model, showing, as I told you, top level. But here we have these small bits here of the plastic show again the same of the type 3, that the thickness, the growing of the plastic to prevent the touching of the bottom side of the cursor towards the front face of the body are small elements. Why? Well, maybe it's a lesson learned from the previous, okay? But also the idea is that this is a big pocket slide rule with lots of scales, and maybe taking a little more space would make this too big to handle. So they decided to use also this thing, and then again you have text and lines near to the edge of the slide rule. Okay? So as we have eliminated the hole here, we have been able to close the hole for placing the strap. The strap is better placed and also it's better fixed. So it's an improvement taken from this small decision for the assembly line. I don't know, you have tried sometimes to get 2 or 3 cursors in your table. In this type, the spring remains in place, while in the others, the spring will fall down. So there's an improvement in the assembly process already with this small decision here. Okay? Yeah. Okay. The fourth type is, the idea is that this is again inserted, this is again inserted. Okay. Some holes here. This plastic heating may prove that when you inserted or when they inserted these elements were using some heat. So they again melted somehow the plastic. So the text, first, this is the same, and here we have a special shape. You see here flat, here is flat, and here is some edge. Why is this? This is ultrasound welding, printing, sorry. Okay, I can show you a little bit about how this ultrasound is done. So in ultrasound we have again a metal head. We have the text coming out from this metal head, but when the head touches the plastic, the metal head starts to vibrate. This is the ultrasound vibration. This ultrasound vibration causes friction here. And it's the friction that produces heat. And this heat is then melting the plastic. So in the end, only this area is heated. Okay? So the punch is coming into the plastic, and then it's making the whole movement, but once it's still here, the ultrasounds are stopped. So as we have the whole head is cold, this is fast cold, and then when it retires, you get these flat surfaces showing this ultrasound printing. Okay? So the idea is that this is high quality, but with the lessons learned of type 2. Because if they have found good opportunities for production optimization, why not to use in the high level again? So, thank you, my team of supporters from Spain. I had to look at a lot of slide rules, and Dieter for the indication on the assembly line. He had to read his notes and so on. And biography, have some nice pictures on plastics if you want here. Open point for the future if somebody wants to get an indication on the pictures. It was difficult for me to have good pictures. For example, this one shows very nice colors, but was not showing exactly what happened here. And this is a tricky picture, but you can see here clearly that there's a hole of the thermal printing, and there's a paint white inside this hole. Okay? And I have put the picture here in this shape because when you put that in horizontal, astonishingly, you can see here an effect like showing that the white is coming out. So it puzzled me somehow because this picture I was absolutely misguided, thinking that the painting was very thick and coming out, and there was something strong. Then I look up again by my eyes and realized it was a trick in the picture. Okay, thank you.
I think that's one of the sort of reasons why I like this horrible hobby of ours. We get such incredible research and scholarship. Thank you, Jose. I think that was incredible. I've learnt more than I ever wanted to, I think. But in no way. Can I suggest that we now take an executive decision? It's tea and coffee time outside. Time to have a yawn and a scratch. Klaus, can you start immediately after coffee?
Yeah.
That gives you a chance to set up. David after that. And